Ever get tired of like all those little digital chores, know? Like booking flights and scheduling meetings and making presentations. It's all so time consuming.
Well, that's not science fiction anymore.
Wouldn't it be amazing if you had some kind of like AI assistant that could handle all that for you right from your computer screen?
Yeah, we're going to dive into the world of UI TARS. It's an AI agent from ByteDance, and it's designed to do just that.
Mm.
Interacts with graphical user interfaces the same way you and I do.
So we're talking about AI that can actually like see the screen and click buttons and navigate apps just like a human user.
Exactly.
That's pretty mind-blowing.
And to really grasp like what makes UI TARS so revolutionary, I think we need to take a quick look at how we got here. AI that can use computers has been a goal for a long time, but earlier attempts were pretty limited.
I remember those old chatbots. They could barely answer like basic questions, let alone book a flight.
Right. Those were like the first generation rule-based agents. Think of them as robots following a strict set of instructions.
Yeah.
Then came agent frameworks powered by large language models like GPT-4. A definite step up, but still requiring lots of hand-holding.
So smarter, but still needing a programmer to hold their hand through every step.
You got it. But UI TARS is different.
Okay.
It's what we call a native agent model.
Mm-hmm.
And that means it learns directly from visual input the same way we learn by observing and interacting with the world.
That's a huge leap. So instead of needing step-by-step instructions, UI TARS can figure things out on its own.
Absolutely. So let's say you need to create a presentation.
Okay.
UI TARS can open the presentation software. It can understand the layout of the interface and start putting together slides based on your instructions.
Wow, that's impressive. So how does it work? What gives UI TARS this ability to learn and adapt like that?
It all boils down to 4 key capabilities: perception, action, reasoning, and memory. Let's start with perception.
Okay, so this is all about how UI TARS sees and interprets what's on the screen.
Exactly. UI TARS takes a screenshot. And it doesn't just see a bunch of pixels. It identifies all the elements, buttons, text boxes, images, and understands their function and how they relate to each other.
I'm guessing that's no easy feat. Interfaces can be pretty complex with tiny icons and overlapping elements.
You're right. It's a huge challenge. That's why they trained UI TARS on a massive data set of millions of GUI screenshots. And they use 5 specific training tasks to teach it how to describe elements, understand captions, recognize changes in the interface, answer questions about what it sees, and even connect visual elements to specific functions.
It sounds like they really threw everything they could at it to make sure it truly understands what it's looking at.
And that's crucial because perception directly informs the next capability action.
Okay.
Based on what it understands about the screen, UI TARS can then take actions, like clicking buttons, typing text, scrolling, just like you would.
But clicking the right spot on a tiny icon, especially in a crowded interface, that can't be easy.
Yeah.
How does UI TARS manage that level of precision?
They tackled this with something called unified action modeling.
Okay.
Think of it this way. Imagine you have to control a robot arm to pick up objects. It would be a lot easier if you could use the same commands to move the arm, regardless of what kind of object it's picking up.
Ah, so instead of needing a different command for every button or icon, it has a standardized way of interacting with anything on the screen.
Precisely. That ensures that UI TARS can accurately ground its actions, hitting the right target every time.
Okay, so we've covered seeing and acting, but how does UI TARS decide what actions to take in the first place? Does it just randomly click around?
Not at all. That's where reasoning comes in.
Okay.
This is one of the most fascinating aspects of UI TARS. It can actually reason about what it sees and decide on a course of action, much like a human would.
So it's not just reacting to what's on the screen, it's actually thinking about what to do next. How do they even begin to teach an AI that kind of reasoning ability?
Well, you probably use 2 distinct modes of thinking every day without even realizing it. Think about when you're driving a car. You don't consciously think about every little detail. You just react instinctively based on your experience. That's system 1 thinking, fast and intuitive.
Right.
And then there are times when you have to really stop and think things through, like when you're planning a trip or solving a complex problem.
Yeah.
That's system 2 thinking, slower and more analytical. And what's incredible is that UI TARS uses both.
Oh, wow.
It uses System 1 for quick, familiar actions and System 2 for more complex tasks that require planning and strategy.
So it has a fast thinking mode for routine actions and a slow thinking mode for when it needs to really figure something out. That's remarkable.
It really is. To train its System 2 reasoning, they exposed UI TARS to a massive data set of 6 million GUI tutorials.
Wait, 6 million tutorials?
It is. This allows UI TARs to not just learn how to click buttons, but to understand the logic behind those clicks. It can break down complex tasks into smaller steps, maintain consistency over long workflows, and even engage in trial and error learning from its mistakes.
So it's not just following instructions, it's actually learning to reason about the task at hand. That's a huge step towards AI that can truly understand and interact with the digital world.
You're absolutely right. And there's one more critical capability we need to talk about: memory.
Okay, so this is about how UI TARS learns from its experiences.
Exactly. Like us, UI TARS has both short-term and long-term memory.
Okay?
Short-term memory helps it keep track of the immediate context of a task, like what it just saw or did. Long-term memory stores its knowledge about different interfaces, the tasks it's performed, and what worked and what didn't.
Ah, so it remembers its successes and failures. That's how it learns to get better over time, right?
Exactly. And they've even implemented this amazing technique called online bootstrapping. Basically, UI TARS is constantly learning on the job.
So they just let it loose on a bunch of virtual computers and let it learn by doing.
You got it. It tries to complete tasks, makes mistakes, learns from those mistakes, and gets better over time.
That's incredible. It's almost like it has a digital mentor guiding it through the process.
They even have a process called reflection tuning, where human annotators help UI TARS learn how to recover from its errors, making it even more robust.
That's some serious next level AI. So we've talked a lot about what makes UI TARS tick, but how does it actually perform in the real world? Can it compete with other top AI models out there?
Well, hold on to your hats because the results are pretty amazing.
Okay, I'm ready. Tell me everything.
So UI TARS was tested on a variety of benchmarks, including Osworld and Android World, which use real-world web and mobile applications. And let me tell you, it really impressed the researchers.
Can you give us some specifics? What kind of tasks did it excel at?
Okay, so on Osworld, which uses real-world web and desktop applications, UI TARS blew other top models out of the water. It achieved a score of 24.6, while the well-regarded Claude model only managed a 22.
Wow.
On Android World, it tackled complex tasks across a range of mobile apps, achieving an even more impressive score of 46.6. This really shows UI TARS's versatility and adaptability.
That's really remarkable. UI TARS is clearly pushing the boundaries of what AI can achieve, and to think this is just the beginning.
Exactly. And this brings us back to the System 1 versus System 2 experiment we
Yeah.
touched on earlier.
Right, the fast thinking versus slow thinking.
Yeah.
I'm really curious to hear more about how those two modes impact UI TARS performance.
Well, stay tuned because when we come back, we're going to dissect that experiment and uncover some surprising insights about how UI TARS thinks and learns.
This is one deep dive you won't want to miss. We'll be right back.
Welcome back. Remember how we were talking about UI TARS having those two modes of thinking, System 1 and System 2?
Yeah, the fast intuitive thinking versus the slower, more analytical approach.
Yeah.
It's like having a multi-speed brain. So what happened when they put those two systems head to head?
Well, they ran a really clever experiment to see how each system performed on different types of tasks.
Okay.
So imagine you're taking a test. Some questions are straightforward and you can just rely on your gut instinct.
Right.
And then other questions you might need to really stop and think, maybe work through the problem step by step.
Yeah.
So for UI TARS, they use something called in-domain tasks, meaning things that it had already encountered during its training,
Okay.
and out-of-domain tasks, which were completely new challenges.
So like testing a student on material they've studied versus throwing them a surprise pop quiz.
A perfect analogy. So for the in-domain tests, they used benchmarks like Multimodal Mind 2 Web, Android Control, and GUI Odyssey.
Okay.
These involve tasks like navigating websites, filling out forms, and executing commands on mobile apps.
Yeah.
Stuff UI TARS had already practiced.
So familiar territory. What about the out-of-domain challenge? What did they throw at it?
They used a benchmark called Android World.
Hmm.
It simulates a live Android environment and throws all sorts of tasks across various mobile apps that UI TARS had never seen before.
Talk about a pressure test. So how did UI TARS handle those unfamiliar challenges? Did that slower, more deliberate System 2 thinking give it an edge?
That's where it gets interesting. For those familiar in-domain tasks, when they only let UI TARS generate one solution, System 1 actually did better.
Wait, really? But I thought System 2 was supposed to be the more advanced way of thinking.
It is, but it also involves those extra thinking steps. And sometimes when you only have one shot, Taking those extra steps can actually lead you astray,
Yeah.
especially if one of those steps is based on like a faulty assumption.
Ah, so it's like overthinking a simple problem. Sometimes the simplest answer is the best.
Exactly. But when they allowed UI TARS to generate multiple solution candidates, System 2 pulled ahead.
Okay.
With more options to choose from, those extra thinking stacks became an asset, helping UI TARS explore different approaches and arrive at the right solution more often.
So system 2 is like having a team of advisors weighing in on the best course of action.
A great way to put it. And this advantage was even more pronounced in those out-of-domain tasks on Android World.
Uh-huh.
Even though UI TARS was facing totally new challenges, System 2 significantly outperformed System 1.
So it's like having a skilled explorer navigating uncharted territory. They might take a few wrong turns, but they're equipped to analyze the situation, adapt, and ultimately find their way.
Exactly. This really highlights the power of System 2 reasoning for AI agents operating in the real world. It's not just about following a set of pre-programmed instructions. It's about understanding the problem, considering multiple options, and finding the best solution, even when the path isn't clear.
This experiment is incredibly insightful. It shows that AI can move beyond just fast processing and into the realm of thoughtful, strategic problem solving. It's a huge step forward.
Absolutely. But like any new technology, UI TARS has its limitations.
Okay, so it's not a flawless digital genius. What are some of the areas where it still needs to improve?
Well, one challenge is scaling it to handle a much wider range of tasks and environments. Remember, its training data set, while massive, only covers a fraction of the digital world.
So it's like UI TARS has learned to drive in a small town, but navigating a bustling city with all its complexities is a different beast altogether.
Exactly. Another limitation is that most of its training takes place in simulated environments.
Okay.
And while these are incredibly realistic, they can't perfectly replicate the messiness and unpredictability of the real world.
So it's still kind of sheltered. It's like it's learned to swim in a pool, but hasn't yet tackled the ocean waves. What would it take to get it ready for those real world challenges?
One approach would be to train UI TARS directly on real-world data, using techniques like reinforcement learning.
So instead of just being told what to do, it would learn by actually interacting with the world, receiving rewards for success and penalties for errors.
Exactly. It's like letting a student learn by doing rather than just reading textbooks. This would help it adapt to the unpredictable nature of real-world interfaces.
That makes a lot of sense. So UI TARS is a groundbreaking achievement with incredible potential, but it's still a work in progress.
Absolutely. As with any powerful technology, it's important to consider the bigger picture.
What do you mean by that?
I mean, the potential impact on various aspects of our lives, how we work, how we learn, and even how we interact with each other.
These are big questions. So where do we go from here? What's next for UI TARS and the future of AI that can use our digital tools?
Well, stay tuned because when we come back, we'll explore those very questions.
Yeah.
We'll dive into the potential applications of this technology and what it could mean for our digital future.
Welcome back to the deep dive. We've been exploring this revolutionary AI agent, UI TARS, and I have to say it's really sparked my imagination. If we have AI that can understand and interact with computers the way we do, where could that lead us?
The possibilities are truly vast.
Yeah.
Imagine a world where all those tedious digital tasks,
Mm-hmm.
things like scheduling appointments, booking travel, or even generating reports, are fully automated.
Right.
UI TARS could handle those things, for you freeing up your time and energy for more creative or strategic work.
That sounds amazing, but it also raises some concerns. What about all the jobs that rely on those tasks?
Yeah.
Wouldn't widespread automation lead to unemployment?
It's a valid concern and one that we need to address carefully. But throughout history, we've seen that technological advancements often create new opportunities as they automate old ones.
Right.
It's not necessarily about replacing humans, but about changing the nature of work.
So instead of fearing AI, we should think about how we can work alongside it, each leveraging our unique strengths.
Exactly. Imagine a collaboration where AI handles those repetitive tasks while humans focus on things that require creativity, critical thinking, and complex problem solving. We could see entirely new industries emerge, focused on designing, training, and collaborating with these advanced AI agents.
That's a much more optimistic outlook, and it's not just about the future of work, is it? UI TARS could have a huge impact on other areas of our lives as well.
Absolutely. Think about education. We could have AI tutors that personalize learning for each student, providing customized lessons and real-time feedback.
Right.
Imagine a world where every student has access to a personal AI tutor that can adapt to their individual needs and learning style.
That would be incredible. No more one-size-fits-all learning. And what about accessibility? Could UI TARs help people with disabilities interact with computers in ways that were previously impossible?
Absolutely. UI TARs could empower people who have difficulty using traditional input devices like a mouse or a keyboard.
Right.
Imagine someone who can't physically type being able to create documents or browse the web just by speaking or using eye tracking technology.
That's really powerful. UI TARs could truly make technology more inclusive and accessible for everyone.
hmm
But with all this potential comes some big questions. Like,
Of course. As we develop AI that can learn and interact with the world in increasingly sophisticated ways, it's crucial to consider the ethical implications.
yeah.
We need to make sure that we're building AI that aligns with human values and that we're using it responsibly.
So it's not just about the technology itself, it's about how we choose to use it. What steps can we take to ensure that AI, like UI TARs, is used for good?
It starts with open and honest conversations about the potential benefits and risks. We need collaboration between researchers, policymakers, and the public to establish clear guidelines and regulations for developing and deploying AI responsibly.
It's like creating a roadmap for the future one that leads us toward a world where AI empowers us without compromising our values or our well-being.
Exactly. It's about ensuring that AI serves humanity, not the other way around. And this isn't just the responsibility of the experts, it's something that everyone needs to be aware of and engaged in.
We're all stakeholders in this digital future, and it's up to all of us to shape it in a way that benefits everyone. This deep dive into UI TARS has been truly mind-blowing. We've gone from the technical details of how this AI works to exploring its potential to reshape everything from the way we work to how we learn and interact with the world around us.
It's a fascinating glimpse into the future of AI, and a reminder that the future is not something that just happens to us. It's something we actively create through the choices we make today.
And as we wrap up this episode, we want to leave you with one final question to ponder. If AI can master our digital tools, could it become a true collaborator in our quest to solve the world's most pressing challenges? Could we unlock new levels of creativity and innovation by working alongside AI that can learn, adapt, and reason alongside us?
That's a question that will continue to unfold as AI research progresses. But one thing is for sure. The future of AI interaction is full of possibilities, and UI cars is a shining example of what might be possible.
Thanks for joining us on this incredible deep dive. We'll see you next time.